Okay, today we are on lesson 8.1.2 and we're going to start by exploring the names of these polygons, right? So we're going to start by talking about how do we call these polygons with the number of sides, and most of these you know already, so there should not be a lot that you have to spend time to memorize. So any three-sided shape, we call them triangles, right? And of course, there's specific ones. There's scalene, isosceles, right, obtuse, more details on the triangles. But in general, everybody with three sides are called triangles. Everybody with four sides are called quadrilaterals. Quad means four, right? Quadrilaterals. Lateral means there's sides, so four sides. Now, of course, again, you can go into details and find that there are rectangles, parallelograms, trapezoids, kites, and these are all specific types of quadrilaterals. But the overall umbrella is everybody's named quadrilateral. Okay, five sides are all called pentagons. Six sides are hexagon. Seven's heptagon. Eight is octopus, so octagon. 9 is nonagon. 10 is a decade, so decagon. 11 is an interesting one. It's called hendecagon. And really, after 10, we usually don't give it a name anymore. You can definitely look up all these Latin roots and figure out what the official name is. But after 10, we just call it the number gon, right? So if it's 25, we call it 25agon. 26, we call it 26agon. Okay? All right. And then so we just kind of go into this idea of reminding you that a polygon is a two-dimensional closed figure made of straight line segments connecting end to end, right? So polygon has to be a closed figure and straight line segments, okay? And a regular polygon is equilateral and equiangular, meaning all sides are the same and all angles are the same. So this shape right here is a regular hexagon. It has six sides and every side's the same, every angle is the same, right? And then again, another vocab here, polygon is convex if each pair of interior points can be connected by a segment without leaving the interior of a polygon. So it's harder to define convex. I think it's easier to define something that's concave. Concave is the opposite of convex. Concave is when your shape is caving down, at least one part of it. So for example, this is a convex polygon because everything's protruding out. But this is a concave polygon because there's a part of it that's caving in. So even though a star looks like it is convex because everything is pointing out, this is actually caving in. And the trick is to find, if you take two dots on the inside of the polygon and you connect them, if any part of it goes out, that means there's a concave part of it, so it's not convex. See, any two dots in here, I connect, I will not go outside that pentagon. But if I put two dots here, it will be outside the pentagon. And that's why that one is a concave versus a convex. Okay, all right. So we're going to explore these polygons, these multiple side polygons, and look at the sum of the interior angles. Right, there's a lot of inside angles, and how can we figure out what they all measure and what's the sum? What do they all measure up to? Right, adding them all up. So it says, the pentagon at the right has been dissected into three triangles with the angles labels as shown. Use the three triangles to prove that the sum of the interior angles of any pentagon is always 540, right? So how do I do that? Well, you're going to add up all these angles, right? So it says, and sorry for the typo, this is angles, not angels, right? So go ahead and fix that. So what is the sum of the angles of a triangle? Well, any triangle adds up to 180. So it's always 180 degrees. Add the three equations to it, create one long equation that represents the sum of all 9 angles. So let's go ahead and use the space we have up there. We know that in this picture, triangles A and B and C adds up to 180. Then next angle D, E, and F. So D plus E plus F also equal 180. And then G plus H plus I also equal 180. So it says add all three equations because they're all inside this pentagon, right? So I'm adding all these angles up to represent the sum of all 9 angles. So I go A plus B plus C and add D and E and F and then G, and an H, and I, right? And you know this is 180, 180, 180. So 3 of them makes it 540 degrees. Okay, so substitute 3-letter name for each of the angle of the pentagon for the lowercase letter that at each vertex of the pentagon. So this is what you need to substitute. So is a little bit confusing, but what it's trying to say is, okay, notice how the letter X, angle X here, is really where B is, right? So B, this B got replaced by measure of angle X. Okay, measure of angle Y is the sum of C and E. So C and E, that's measure of angle Y. Okay, and then Z is F and I, so F and I, so measure of angle Z. And then B is just H, so H is here, measure of angle V. And then last angle, measure of angle W. W is made up of A, D, and G, so A, D, and G are, that's everybody, and that equals 540. So any pentagon, any 5-sided shape will add up to a sum of 540. Okay, and there's a really cool trick. This is the trick that we're using. We're using triangles to help us figure out the sum of the angles inside any polygon. Okay, so now let's see. It says, find the sum of interior angles of the polygons below, complete the table. So you see that there is one triangle here. When it's n equals 3 means that's 3-sided. A 3-sided shape is a triangle, and we know the triangle always add up to 180 degrees. Okay, so right here, 3, number of sides is 3, adds up to 180. Okay, what about 4-sided? So the trick is to cut up the 4-sided shape, the quadrilateral, into triangles, but you don't want to overlap any line. You don't want to create smaller triangle. You just want to make sure you make a cut and you got triangles. So easiest way is to connect one of the diagonals, and there you create 2 triangles. And so that's 180 plus 180. So any 4-sided actually adds up to 360. Okay, now, Ms. Chu, why don't you make another diagonal? Because if I make another diagonal like so, you see how I would cut through the original one? You don't want to cut through the original one. So any diagonal you make, you cannot cut through the previous triangle. So what about the 5-sided? Well, we just did that one. You pick one vertex and you go ahead and connect it to an opposite angle to create triangles. And you see you create 3 triangles. So it's 180 plus 180 plus 180. So this is now 540. Okay. A 6-sided, same thing. You pick a nice corner and you go from there and you can make your triangle. This one has 4 of them. So 4 times 180 gives me 720. Okay. Now, Ms. Chu, is that the only way you can do this? Because sometimes it's really hard to go from just one end. No, you don't have to. You can actually go a zigzag. So here's another way to do it. Here's one corner to another, right? And then I can go from that corner to the other corner like so, and then come back down, and then go back, oops, and then go back this way. See, none of my triangles overlapped each other, and I'm able to create individual triangles by just connecting to an opposite angle. So 1, 2, 3, 4, 5. So 5 times 180 gives me 900 degrees. Okay. Now you probably can see the pattern here. Each time you're increasing by one more triangle. Sorry. So each time your sum is increased by 180 degrees. So if you just go ahead and use your calculator or do this in your head, if you add 180 to your 900, the next one should be 1080 degrees. And this is 1260 degrees. And then I believe this is 1440 degrees. And wait, it skipped one. It's now 12-sided. So that means you need to add not just one triangle, you need to add 2 triangles. So that would give me a sum of 1800. Okay. So does the interior angle sum depend on whether the polygon is convex? And the answer is yes. If it's not a convex polygon, then the angle is going to change. So yes, must be convex. Okay. Now, is there a pattern here? There is a pattern. So the sum is equal to the number of sides minus 2 times 180, because the number of sides minus 2 is actually the number of triangles created. look at it. If we look back here, if I have 3 sides, I minus 2, I get 1. 1 times 180, that's my sum in the triangle, right? N equals 4, so I subtract 2, I get 2. 2 times 180, that gives me 360 here. N equals 5, so I subtract 2, I get 3. See, 1, 2, 3, 3 triangles. So if you subtract 2, that's the number of triangles you have left in your polygon, and then using that to multiply by 180, that will give you your sum. That gives us the next piece. Find the sum of an interior angle of 100 agons. So this thing has 100 sides. It's a pretty big shape, right? And how do you find the sum? So my N is 100. Following that formula, you would take 100 minus 2 times 180. So that's 98 times 180. And no, don't do this in your head. Use a calculator if you need. So 98 times 180. And I get the sum to be 17,640 degrees. All right, and it says explain your reasoning. This is your explanation. This is your formula that is going to be your bread and butter for finding the sum of the interior angles of any polygon. Okay, now let's see. Using that relationship, I know I apologize. The problems are a little out of order because of the way I needed the space. So we're not going to jump back to 8-16. And you need to first look at how many sides you have, or at least how many angles you have, right? Sometimes it's harder to count the sides, so I just count the angle. So I go, okay, this one has 1, 2, 3, 4, 5, 6, 7. Perfect. So that means it's a 7-sided, it's a heptagon, and that means my sum is 900. Okay, great. Then I take all the numbers here, and I'm going to line them up. Sometimes it's actually easier to line them up vertically, right? I get 138 plus 106. And m minus 9, m, 133, 120, m plus 13, and that will equal to 900, right? So that way I can see, oh, I got 3 m's. Okay, I got some calculator work here. So 138 plus 106, don't forget it's a minus 9, and plus 133 plus 120 plus 13. Okay, that gives me plus 501. Okay. Then algebra says subtract 501 on both sides. Okay, so that gives me 3m equals 399. So m equals 133. And I believe it's just solve the variable. So I did. That is the variable m. Okay. All right. The next shape is a hexagon because I see 6 of them. So that means then my sum that I'm looking for is this one. It's 6-sided and it's 720. Oh, just my luck. Every single one of these angles is x. So I can just count and go 1, 2, 3, 4, 5, 6. So 6x equals 720 because that's the sum of a hexagon. So then divide by 6 on both sides. X is equal to 120. Okay. All right. How about down here? It's getting a little bit tougher, right? We got more pictures here. Okay. Let's start with what we know. This is a triangle. And this is isosceles, which means these two are the same. Even though they didn't ask us to find that, we need to find that in order to find k at the very end. So we need to work on that first. So that means if I call this x, this is x. So 64 plus 2 x's equals 180 because that's a triangle. Subtract 64 on both sides. You get 2x is 106. No, 116, sorry. 116, right? 180 minus 64. Okay. I then divided by 2. Divided by 2, you get 58. So x equals 58, right? So why is that important? You get 58 here, right? And then you see that, oh, actually right next door, this makes it a linear pair. So what must that be? 58 plus what gives me 180? Okay, so I take 180, take away the 58. That gives me this angle as 122. Okay, perfect. So that's what I want. Now I look at this shape here, and it's 1, 2, 3, 4, 5. It's a pentagon. So a pentagon adds up to 540. So then I take the angles I have and start counting, right? This is a 90 degree. So 90 plus 122 plus 88 plus k plus 96 must equal 540. Okay. All right. So I'm going to use my calculator because there's a lot of numbers here. 90 plus 122 plus 88 plus 96. So k plus 396 must equal to 540. So k K must equal to 144 degrees. Okay, all right. Okay, in this next picture, you see that you have some extra information. You know that these are parallel lines, right? And then this thing that cuts through, that's a transversal, right? So I don't know much, but I do know that these two angles are same side interior angles, right? So they're going to add up to 180. I don't care what they are individually. I know they add up to 180. So these two together makes 180. Okay, now I look at the shape I'm really tackling. It's a 1, 2, 3, 4, 5. So it's a pentagon. So that means that it equals 540. So I take these two angles. I know they add up to 180. So 180 plus this angle 135, and then the 2y, and then the 3y, right? So 180 plus 135, that gives me 315. This is 5y equals 540. Subtract that 315 from 540. I get 5y equals 225. So then y equals 45 degrees. Okay, all right. Last but not least, take some time to review the special quadrilaterals that you went over in chapter 7. Really look at the properties of each of these shapes, the parallelogram, the rhombus, the rectangle, and isosceles trapezoid. What makes them a parallelogram? What makes it a rhombus? And what makes it a rectangle? It's important to know these properties because it will help you solve for the missing stuff. Okay? All right, that's it, guys.